The energies E for the first few states of an unknown element are shown here in arbitrary units. So here are the energies, -11, -5, -2, -1. We're not given units, but it's very nice that these values are integers. And by first few states, it's talking about the principal quantum number n. So if an electron is in n equal 1, it's going to have an energy of -11. If that electron occupies n equals 2, it's going to have an energy of -5. And if that electron completely leaves the atom, overcomes the nuclear attraction, it's going to have n equals infinity, and that will be an energy value of 0. So a gaseous sample of this element is bombarded by photons of various energies in the same units of this. So we look at photon A, has an energy of 11, photon B, energy of 9, etc. So we need to match each photon to the result of its absorption or lack thereof by an n equal 1 electron. So we're looking at an electronic transition of an electron in the first energy level going to perhaps the second energy level, or the third energy level, or the fourth energy level, or perhaps even getting ejected from the atom. We're looking to see if any of these photons have the energy that is required for these transitions. So let's look at photon A. It has an energy of 11. If we look at the change in energy of this electronic transition, delta E, it's going to be the final energy minus the initial energy. And we know that's going to be the final energy state minus the initial energy state. So for this photon, our initial energy is always going to be -11 because it's always starting out in the first energy level. And if you remember, the energy of an electron being ejected when our n level is infinity is 0. And we know that 0 minus -11 is 11. So photon A has the exact energy required to eject this electron. So I'm going to match that to photon A. Now let's look at photon B. Photon B has an energy of 9. If I'm starting out at n equals 1, it means my energy is -11. If I look at energy level, my third energy level here, n equals 3, and I take my final energy, -2, minus -11, that actually is going to be 9. So photon B has the exact energy required to get from my first energy state to the third energy state. So remember, when we're calculating our delta E, it is always the final minus the initial. So I'm always starting in this problem at n equals 1, that energy is -11, and the energy of my n equals 3 level is -2. So -2 minus -11 is +9. Alright, I'm not going to do photon C and photon D, and I certainly hope that your values are different than these, so you're not just copying my work and you can have the fun of doing this all on your own.